4 is a problem with overlapping triangles. We got that small triangle there with a larger overlapping blue triangle here. And I know whenever I have overlapping triangles, right, that whole entire idea of overlap triangles, that means they're similar, and if triangles are similar, we can solve them with a proportion. All right, that's how we're going to do it. And a proportion is a fraction equal to a fraction, right? So we just kind of got to separate these triangles. We're going to separate that triangle. I'm going to record that this side was 1. I do not know this side or this side. I'll pull out my blue triangle, put it down here, and I can tell that this blue side here was that original 1 plus the other piece, 3.5. So 1 plus 3.5 is 4.5. So I know this side is 4.5. And then they're telling me this entire side, from D all the way to A, that's 18. What they want me to find is the length of AE, rounded to the nearest tenth. So I'm looking for this side. And this is a very easy proportion to make. I'll fill this one in here. So you can make the proportion a bunch of different ways. The idea is you just got to match up corresponding pieces and be consistent. So I'm going to do the small triangles on top and then the big triangle on the bottom. And I'm going to match this side of 1, I'll put up here, and that's going to correspond to this side of 4.5. And then I got to repeat that pattern, something from the small divided by the corresponding piece from the larger one. And then we'll do butterfly multiplication to solve for x. So 4.5 times x is 4.5x. 1 times 18 is still 18. Divide both sides by 4.5, 4.5. That will tell me what x equals, and I'm far too wise to try and do this by hand, and honestly too lazy. I'm just going to do 18 divided by 4.5 on my calculator. Oh, it's 4. Great. So x would be 4, and there's no rounding involved with that. That's kind of like a little trap there, apparently. See you in the next one.